If f and g are both differentiable, then the product f and g, when we take the first derivative, it will be f of x, keep the same, and then times the first derivative of g of x plus g of x, keep the same, times the first derivative of f of x. We want to do the proof for this, so we begin from the first derivative of the product g and f. Then by definition, this is the limit of the function at x plus h minus the function itself divided by h. Now we're gonna place the little trick in here. So what do I do is this, I keep the same. This one, I keep the same. And then we add and subtract the same number so that will become 0. So I don't change the original problem. So we add and subtract f of x plus h times g of x. And after that, we group the first two together and the last two together. We have a plus in the between, so it's a limit of the sum, is the sum of the limit. Then we recognize that we have f of x plus h are the common factor, so we factor this out. And for the second one, we have g of x is the common factor, so we factor it out. So now we have a multiply between these two, so it's equal to the limit of 1 by 1. The limit of the product is the product of the limit, so we separate them. And because h approaches to 0, so the h is gone, so we have left with the f of x. And this part is, by definition, this is the first derivative of g of x. Limit of g of x, as h approaches to 0, there's no h in here, so g of x is like a constant, so it's equal to g of x. And the limit of x plus h minus f of x divided by h, as h approaches to 0, is definition is the first derivative of f of x. So we're gonna do example number 1 to apply for the rule, product rule. We have the multiply between the x and the e to the x. So we want to take the first derivative of x times e to the x. So it's equal to, so this will be the function f of x, and this will be the function g of x. So we have the product rule in this step. So we're going to apply this. So that would be f of x times the first derivative of e to the x, which is g of x, plus g to the x, e to the x, which is g of x, times the first derivative of f of x, which is x. So e to the x, the first derivative is e to the x. It's the same. The first derivative of e to the x is e to the x. The first derivative of x is 1. So we can factor out, then we got x plus 1. Now the problem in part B wants us to find the nth derivative. So we continue to find the second derivative. So let's write it down. F prime of x is x plus 1 times e to the x. Then the second derivative, this will become f of x, and x plus 1 become g of x. So we take the first derivative of g of x and keep the f of x. We apply the formula, right? So the first derivative of x plus 1 is 1 plus x plus 1, and then e to the x, the first derivative is e to the x. Now simplify this a little bit, so we can factor out the e to the x, so we get 1 plus x plus 1. Simplify inside the parentheses, so we get x plus 2. So let's do two more, the third and the fourth derivative, then we will see the logic, okay? So this will become the function f of x, and this is the function g of x. So we will have e to the x, the first derivative of x plus 2, plus x plus 2 times the first derivative of e to the x. Then the first derivative of x plus 2 is 1, and the first derivative of e to the x is e to the x. We factor out e to the x, so we got 1 plus x plus 2, and that will become x plus 3 inside the parentheses. Okay, now we do the last one, x. When we want to do the fourth, the derivative, then this will become the f of x, and this is g of x. Then we will have e to the x times the first derivative of x plus 3 plus x plus 3 times the first derivative of e to the x. X plus 3, the first derivative is 1. The first derivative of e to the x is e to the x. We have e to the x are the same common term, so we can factor out. So we get 1 plus x plus 3. Then e to the x plus 4. Okay, so now let's go back and pay attention to the answer. So the first derivative, you have e to the x. The fourth derivative, you have to e to the x. The second and the third, you have e to the x. Multiply the parentheses. For the first is x plus 1. For the second is x plus 2. For the third is x plus 3. And for the fourth is x plus 4. So by doing the logic, so we will have that the answer for the n derivative will be e to the x plus n. So n will be 5 if we want to take the fifth derivative. And if we want to take the sixth derivative, n right here will be 6, okay?